people should feel more relaxed. You got 9 minutes longer break, so I hope everybody's feeling better. And we still have team if there is any follow-up questions. Otherwise, we can go to the next presentation where all the questions resolved over the coffee. Yes? Okay, there's gonna be more chances, okay? So next presentation, go ahead. This guy can open the door for you.
Ah.
Hi, everyone. So this is another topic on how we evaluate our like video enhancement Gen AI product experience using the subjective and objective evaluation. And we use a case called auto dubbing, which is a newly launched product feature as a case study. And Shankar is actually here, joins right at the time. He is also a key contributor to this evaluation. So he's my manager. Do you want to
introduce yourself first?
Yeah. Hello, everyone. My name is Shankar. I work in the media algorithms team in Viper along with Yanni and a few others. Thanks so much for your time.
Yeah, so for today, we'll discuss 3 topics. First is what are the challenges facing the Gen AI media innovation, and what is the gold standard of algorithm benchmarking, and finally, how we evaluate the quality using the objective metrics. So this is a quick demo of this Meta AI translation feature. It's short, but helpful to understand this experience.
Before you start, the microphone and use your speakers because you don't have the audio connection to Zoom.
Okay.
Somehow. I don't know, you know how to enable audio here? Because yesterday I did just put the microphone in, it works. I don't know how you enable audio here. Here is where the Zoom client is, right? You know what I mean? This is the one dialing the Zoom and you're just, you know what I mean? So anyways, let's go like this.
Mm-hmm.
Just where is your speaker here, right?
Okay.
Okay, hold it close and play.
Sure.
De coco, banana y dulce de leche. Esta receta fue una de las primeras que subí a las redes. Hace poquito la volví a descubrir y le hice un par de modificaciones para que sea aún más deliciosa. With coconut, banana, and dulce de leche. This recipe was one of the first ones I uploaded to social media. A little while ago, I rediscovered it and made a couple of modifications to make it even more delicious.
Mi lengua materna es el español, pero fíjate, ahora también puedo hablar inglés a través del doblaje automático de IA. Mis labios se sincronizan con la traducción y todo. Es increíble. Qué cool poder conectar con personas y audiencias que hablen inglés. My native language is Spanish, but check it out. Now I can also speak English through AI automatic dubbing. My lips are synchronized with the translation and everything. It's amazing. How cool to be able to connect with people and audiences who speak English.
Yeah, so this is a yeah, I think the credits should go to the research and the product team, and to our team as well. So as you can see, this is Gen AI translation that you translate one voice from the other voice in a different language, but still preserve the expressivity and make it sound like you. And also we generated a lip movement meanwhile. So this is a new experience we are launching to, and hopefully will launch globally soon. So next we want to talk about what kind of challenges we faced when we productionize this new experience. I think the major challenge we face is the data and the concept drift when we are launching this research model to product. So the research model here we reference is the seamless expressive. It is like speech-to-speech translation and preserve the expressivity. And when launching this model, there are several challenges. First, for example, the model is trained based on a clean speech signal. There's no noise at all. But in our product, in our short form video, there are background music, background ambience noise. It could be more complex than this research training data set, meaning that the pristine research model is not able to handle this complex use case. And the implication is that a lot of the objective metrics that are used to evaluate this model is no longer effective. So when the research achievement was published by our FAIR team, it was evaluated given an input audio as input, given audio as input, and given audio as output. And there are a bunch of research metrics deployed to evaluate the speech translation accuracy, whether the content makes sense, what is the similarity between the translated and original audio in terms of the preservance of the expressivity, and also about how similar is the translated voice sounds like the original speaker. But all those are not effective at all because we are using a different data, it's a product data. And it ends up a more complex system because we need to handle, to pre-process and post-process a lot of those videos in order to fit the requirement of the research model. So that means more complex system as well. And in this slide, we summarize all the challenges we face when we are productionizing this model. The first is, in this very complex setup, how we can benchmark different algorithms in order to pick the right one. And also, because research metrics are no longer effective, how we can use or identify objective metrics to evaluate the quality automatically. And also, how can we predict the impact, the quality improvement of deploying a certain algorithm. And finally is how to understand the potential risk of the algorithm. And also, we cannot afford to open this new feature without fully understand the risk, because it could be a lot of hallucinations, and we cannot just launch the public A/B testing without well understand the baseline. So now we're going to talk about how we do the algorithm benchmarking. The gold standard we use is still the subject evaluation, and different from the super resolution we just talked about, we use 3 videos side by side during the subject evaluation. So we present a source video, which is in the original language, and also 2 translated versions. The 2 versions are translated by different algorithms or models, so that we can benchmark which one is better. So we defined several audio-visual quality axes in order to capture the overall experience. For audio part, that include the translation accuracy, meaning about whether the meaning makes sense and how well it preserve the original meaning of the speech, and also about audio quality degradation. It's about the level of degradation compared with the original on the speech and ambience noise. And third part is about the prosody similarity. It's on the similarity on the rhythm, the emotion, intonation, emphasis, and also about the voice similarity. Is at what level the translated voice sounds like the original speaker. And also we define 2 visual quality axes about the lip sync accuracy. How well is the mouth movement aligned with the speech, and also the naturalness. It's more like, is the generated lips, teeth, and facial movements sounds like natural, sounds like a real person. And finally, we have an overall dimension, quality experience dimension is called shareability. It's more like the overall user preference. If this is a video is generated for you, would you like to share this to your social network, to other people? It's a high level capturing the user sentiment. And similarly, we set up this evaluation. So for the sake of time, I just skip, as we already covered in the previous evaluation. And we also analysis to correct the human bias, inconsistency, and ambiguity. And also did the cost efficiency analysis to select the optimal number of videos and annotators. And here is how we use the subjective evaluation results. The first use case is we use the subjective rating score to set up the exit criteria for the product quality. And for example, in these two charts, there are about 3 quality axes about translation accuracy, voice similarity, and overall the user shareable preference. And this is about English to Spanish translation direction. And here you are seeing 3 bar charts because these are related to 3 rounds of subject evaluations over the time. And let's focus on the orange bar. That has using a version analysis version has tighter confidence interval, and we are able to see that as engineers are improving the quality, we do see the preference of the subject evaluation is also going up, indicating the quality is improved over time. On this translation accuracy. However, on other quality axes like voice similarity and shareability, we can see some short-term mixed movement. So we use this chart to track the long-term quality progress. And we also use this part. There's a green line. A green line means the exit criteria. And we are using this whether the green line is within the confidence interval to make a choice, to make a decision whether we are about to hit the exit criteria. The second use case of the subject evaluation is also benchmarking several rounds of evaluation model results. In this part, we have 3 charts using the paired t-test. The 3 charts are related to text translation accuracy, shareable preference, and voice similarity, 3 quality axes. And the different color means different level of the statistic. Like the green bars means there is a statistical significance of the model quality improvements, where the red bar means there's a statistic regression of the quality, and the gray bar means there's no statistic change at all. And here we are using the earliest round of model quality as a baseline to compare the quality, and we are able to see that over the time, there's a latest round of evaluation that achieved the best quality, while in the middle there is some round of evaluation that regress the quality. We are using this evaluation to benchmark the quality over time. And it's also help us to understand the trade-off, because in some time, like, because we have so many quality axes, when you are improving the model, it's very oftentimes you cannot move all the quality axes. It's more likely some of the axes are improved, but some of those are regressed. And we also use this to understand the magnitude of trade-off among the quality axes in order to make a wiser decision. And now I'm going to talk about the objective quality metrics we use to evaluate this experience. And as we mentioned, objective metrics are very useful for us to identify the eligibility criteria, whether we should apply this model to a certain type of content at all, and also predict the upfront quality improvement and so that we can predict the ROI. And also we can use this objective metrics for quality reliability monitoring for our infra. In this case, we use the two metrics we deployed, which are UVQ and LSE. So we already introduced the UVQ, and now let me briefly introduce the LSE. So the LSE is a metric, objective metric that measures the alignment, the synchronization accuracy between the speech and the mouth movement. And based on this, the network prediction of the neural network, it will produce a quality score indicating the level of alignment. So we use these two metrics, UVQ plus LSE, to evaluate the quality of the experience. And for LSE, we calculate the correlation coefficient between this objective score with our subjective evaluation data set, and also get a Pearson correlation score about 0.6, indicating reasonably good correlation as well. So we use this case mostly like how we can proactively detect the low quality samples, because it's more important that we don't want to regress this product experience. That's why detecting those outliers is very important. It's even more important sometimes than having a very amazing correlation score. And we found that by combining these two metrics, LSE and UVQ, we can predict the low quality reasonably good. And those objective metrics are useful for product team to consume and make a wiser decision. Some learnings and also call for action is that what we feel is that based on my understanding or learnings, we're still lacking some protocols that can evaluate our use case. Our use case have two special areas. One is for GenAI. More evaluation protocol is for classic video evaluation. And also for our product data, short form videos, is way longer than the traditional setup. Our video could be in a few minutes, but traditional evaluation protocol, their suggestion is in like tens of seconds. So this kind of mismatch will kind of introduce some blind spot, because some issues that is not happening in a very short video in tens of seconds can happen in a long video. Like the speech is not very consistent, it sounds different people saying the same speech. So for those kind of evaluation, if we can have some long protocol for long videos, it will be very helpful. And the other thing we found is how to calibrate the rater drift. So here is an example on the rater drift. We want to track the model progress, model quality over time. But because of we are using the crowdsourced annotators, across different evaluations, the annotators can be very different. And that means even for the same set of videos, when rated by two set of raters, the scores can be very, very different. And even if we apply this serial analysis, it still cannot be fully calibrated because of this kind of bias. And to resolve this, we apply some mean shift approach to offset this kind of bias because of the raters. But we are still seeing that because we are evaluating across multiple rounds, the error because of the mean shift can be accumulated, and finally making the future rounds of evaluation doesn't make sense. It's over offset because of the accumulated error. For me, I haven't found a better solution, but if there is such kind of solution, I think it will be very helpful for us. Yeah, I think that's all for this presentation. Shankar, do you want to add something?
Hi, everyone. I just want to say that this is relatively like a new area of investment in Meta we're doing. Again, thanks to Yanni and others and the great work done by VQEG, we've been able to leverage some of the techniques to improve the subjective evaluation protocol and so on. But again, so I think there's a significant opportunity. I feel like there's a very untapped space and we are just scratching the surface. So we would definitely love to collaborate more with other folks who are interested in the space and make progress. Thank you.
Okay, thank the speakers. I will reserve my own thoughts for last, but opening up for questions to the audience first.
Sorry, me again. Thank you so much. First of all, about the long-term protocols, I think you can check Lucian's work, Lucian Janowski from AGH, and you can speak to Kamil and the others because they have invested into that. So that's just a plug-in from a different group. You're welcome. And for my question, you mentioned that you don't care that much about the correlation, that 0.6 is okay, and you were able to make this very useful for your production team because you are able to identify these bad offenders. And could you just give us a little bit more view into how you, what do you use to actually calibrate it in that particular application? So for example, to identifying these bad cases, what you used, how you treated the data that you had from the experiments, and yeah, if you could provide any more information.
Yeah, I want to give sort of a high level thing because, you know, so sorry. I want to sort of explain and give a high level intuition on this. And I'll let Chi chime in, right? So first is I don't want to say that 0.06 is sufficient correlation. We are happy with it. So the first thing is this is like a sort of a 0 to 1 thing for us. And having some metric is still used better than having no metric, particularly for like monitoring and so on. So that is one. The second intuition, again, this is something we also are developing in the space is sometimes people think, hey, objective metric should completely replace subjective or like have a very high standard for completely eliminating subjective. I think that is completely fair. But, and again, particularly if you look at, say, normal video encoding itself, it took many, many years before we got to like some state-of-the-art metrics like VMAF, which can be used. And for a long time, we had this moving from like PSNR to SSIM and so on, many generations of metrics. What we are finding is there could be usefulness of metrics even without reaching the very high bar like VMAF has reached and how to make use of it. And again, so one area in particular is for us, a metric, even if it can predict that the low quality experience at a higher accuracy, even if the overall correlation is not very high. If it is can give us good signal, that is still could be useful. And because we can maybe more proactively flag some of these low quality, maybe they are not actually low quality, but it's still good in some cases. So that is the approach we are taking. It's more like, I wouldn't say it's like a perfect approach, but just in the time constraints we are stating is, but definitely we are like, want to hear more about how to best use it.
Just to really quickly respond, I totally get that. I agree with that. And I'm really curious exactly if you can tell us a little bit more how you use the metric, if it's not as good in the way that we normally test them. So that's why I'm actually asking the questions. Thank you for the extra context.
So I think we can share something about the LSE, which is a 0.6 correlation with our subjective test. What we use is that in two ways. For we care about how well this generated video is synchronized with they're synchronized, like the synchronization between speech and lip movement. That is the what is 0.6 measures, but we are more interested in the infra side regression or very apparent quality regression on the viewer side. That's why we also annotated those outliers, like there is a completely mismatch between the mouth movement and the speech. For example, there's mouth movement, but there's no speech at all, or the reverse. We want to make sure that for those kind of outliers, we are able to have a reasonably good precision and recall to monitor that, and with a higher confidence that we can roll back a certain like configuration, model version, or triage that issue to our quality assessment team. So for that time, we annotate actually on those samples, and we want to measure those precision recall. Yes. Yeah.
Thank you for your presentation. Your results are impressive, especially for a person with Spanish as a mother tongue. And I am curious about one thing. You were talking about different subjective evaluations that you have conducted, but you are in an area that has very few, if any, previous experience on that. That means you need to train the observers to tell them what are you thinking about a 5, a 4, a 3, a 2, because mainly in the application you are considering, there are people with total different previous schemes. People who are much more interested, let us say, in audio quality, or people who are much more interested in the delivery of the meaning, or just the minimum one, people who are just interested in being able to understand something. So I am curious about how did you train the observers to be sure that the results you are obtaining are meaningful?
Yeah, I think a very good question. It's actually very challenging for us as well. So what we did is like two-phase. When the model was published by our FAIR org, which is a research oriented org. During their like research, they experiment a reasonably good level of this protocol, which is the baseline of our protocol. And when they are building the protocol, they also build a data set of examples. They use those examples to train their annotators. Like, given the expressivity score, let's say 3, what does it mean? They will have some samples like, if it is about emotion, to be different level of, let's say source video is people crying. And at different level of emotion preservation, they will have some samples. Then let the user know if the score is 1, 2, 3, 4, what kind of results will be like. And they use this to train the annotators. And we are following their same protocol, using their samples to share. But it's also challenging because what we are using different annotators almost for each round. There are some different annotators, and it requires retraining. So that part we cannot fully solve this problem. Yeah.
So I think you actually hit the nail on the head with particularly one thing we couldn't talk about is we actually went through several rounds of false starts, particularly in the methodology. For example, should we get it in like some kind of like a 1 to 5 scale? Should we do pairwise comparison? Should we do pairwise comparison with just binary was not providing enough signal? Can we get sort of a multi-scale pairwise comparison? How to provide samples? Again, it does show like, again, we had to actually throw away the data from several early rounds because it was not very useful for us and we found several underlying issues. So definitely one approach we are taking now is to do some dry runs to get some signal faster, to see whether what are the blind spots, like what do we need to train or maybe some internal dry runs too. And that is again, we don't have a great solution perfect for this.
I promised to give the microphone, but okay.
I do agree that ordinality can be solved. My question was more on cardinality, that is not on the order, but in the labeling of 5 forces.
Right.
Okay, so first of all, again, I'm part of the team, but they did the work, so I don't want to take any credit for work. I just gave some guidance, but I want to make sure that people understand 3 big takeaways. Number 1, things are happening with or without VQEG. Okay, make no mistake. So it's either we go on a moving train or stay out of the train is my first comment. And I think we should get on the train. So that's why I'm very happy that the Shogai team is moving hopefully faster than, I don't want to go through, let me use the word, the user round, okay, proponents, validation step, decide after 3 months, are you going to pay the labs or the labs are going to pay the train is gone, right? So if you have to do this, you have to do it swiftly. Perhaps taking some cutting corners, it's better to cut a few corners and get somewhere than missing the train. First message. Second message is a whole lot of questions, as you just heard from Sankar, are uncharted territory, or where I believe this group has the highest probability of getting the right answer, right? What is the questionnaire? Do you ask all these access to the people, or do you think it's too complicated to have 5 questions? Do you do pairwise? Do you do ACR? I'm not going to continue the list. The list is very big. how many samples how many subjects you call, right? What's the viewing environment, the listening environment? All these methodological, allow me to call it, aspects is one big class of problems that I think we can leverage the existing methodologies, modifying them and getting there. The other part, which I'm not sure you captured well, is that this is active. Most people say, I do a subjective test, I produce a database, I'm done. I publish it, people will use it. No, it has to be done in loop, right? The outcome of that needs to be analyzed like immediately. So maybe tomorrow there will be another round of testing in an ideal world, right? That's really the mode we should be thinking, that this community can actually be the accelerator and enabler of use cases. So these are my thoughts here. And anybody else has questions or comments? And again, call to action. Please join the SOC Guide team if you are not already there. I think there is, because again, I think just like, if I may speak, it's not only Meta that's moving. I know for sure YouTube is moving. And I think initiatives like UVQ that happen outside of VQEG and perhaps can be incorporated in some standard are another case where people just cannot wait sometimes for the, let's say, the life cycle of a VQEG project or an ITUT project or any other standardization organ. So, Pablo.
Yeah, I mean, great ideas, and as you said, Yanni, there's a lot of experience here on how to tackle that. So we should figure out on how to address that. I mean, we've worked on long video evaluation protocols and problems for a while. There are a few groups. I mean, we, like the four of us, did a lot of things in one way. So we have some experience on comparing short-term evaluation with long-term and the caveats and things like that. So we have some experience on that. There's also the team who did all the peanuts evaluation. They also, they had a different approach, but they also have worked with long content. And of course, there's all the work by Camille and Lucian and stuff in the general properties of ACR. And there's a lot of work in IMG on the problem with questionnaires, right? We've been fighting with that. It's for a different use case, but the same problem. Like, we have a lot of questions. We need a small budget on what to ask and stuff like that. So, I mean, we have even, results that can be analyzed and maybe exploited there. So there's a lot of cross-fertilization available, and there's a lot of experience in this room on that. So yeah, let's I think we're all happy to try to kind of accelerate things and simply try things that we know from experience, and then let's see how it goes. So there's no need. I mean, we don't have strong needs for, especially for testing methodology. There's no strong competition, right? So everyone really wants to do the things which works better. So there's no need for long processes and stuff like that. We can be agile.
Yeah, the metrics, I agree, it's going to be very difficult, lots of opportunities. The thing that interests me the most is in the translation, you actually did lip sync for the English version, and the lips, at least from what I could tell, were actually moving. We heard yesterday from Ajit Nainen about the McGurk effect. So the metric, which is that depending on what you're hearing, you can be tricked by what you're seeing. And so to me, that's kind of interesting, because what I saw when the English speaker was speaking, it looked correct for the lip movement. And I'm wondering how you decided on to do that. And, we're going to at some point have to have a metric that, were they really speaking English? Were the lips moving the right way? So, and something Hollywood is very, very interested in. Netflix translates, Disney movie is in 100 languages. So if we can get this to work, we might actually get the Hollywood community to come and get involved as well.
Or not.
Or not.
By the way, the McGirt effect is the other way around. Is how you are. It's okay. Just to, but very relevant actually. We are in the topic for this one. Yes, more than so these days for Gen AI stuff, and I can report a lot of work which are ongoing. It's more, let's say, different from what we are used to do here. Like you have PVS and you have quality and so on. So the things are, and it's not necessarily about metrics. It's about interaction, interactive annotation, So you put some kind of end user in the loop, and as you learn and as you train or retrain your model. So there are a bunch of work on this. And I don't think we really need a metric. Actually, we need to improve the training procedure and how we can put human in the loop from, let's say, subjective experiment to immediately input that in the algorithm. So this is a way we go faster. That's it's a bit different from what we are used to do. Another thing I would like to know, because cross-cultural way to express sentence word. It's not only about the emotion in the voice. It's not only about the lip sync. It's also about some kind of micro expression and stuff like that. So is it something you plan to dig in also?
Are you referring to prosody or something in the visual?
No, it's like prosody. It's already somewhere. No, it's more about the visual. Once again, like Gertefett, you are really affected by what you see.
Yeah.
And it's not only a matter of lip sync. Actually. Because
you're talking about the whole face having expression.
Exactly. Because I just want, once again, I want to make the kind of link with one of the talk we had yesterday and some of the things that we are doing these days with as part of some affective computing modeling project. That yes, we try to better understand in conversation, and especially when you go from one language to another, there's some kind of cultural effect also, the way you're gonna express things. So it's not only about lip sync, So is it?
No, I was just saying we are just scratching the surface here. I don't want to say like for the lip sync in particular, one thing maybe we didn't mention is for the autodub, there was a lot of prior work in the research model that we could build on. And again, we had to do a lot of iterations to standardize. But for lip sync, we had to actually start pretty much from scratch because that was almost a new ask. Hey, that autodub is not enough. We need the lips to synchronize as well. We were not even planning to support it initially. But then we had to sort of support this whole thing and come up with eval in like very tight timelines. So I don't want to say. Chi, do you have any thoughts on going beyond these?
So I think one interesting point is as our lip sync models are more sophisticated, we want to see how well they are able to handle the in the very challenging edge cases, like when the face are angle are very challenging, or there are some occlusion, people holding mags, how we are able to generating those lips. Those could be interesting, and also how far away is the lip sync from the lip reading? Actually, we are able to, given the video as input and predict the content. So I think maybe those are the future directions. As our lip sync model is more sophisticated, we want to check that as well.
Thank you. So again, more food for thought. Okay. Dietmar, you deserve it. Today, for sure, you deserve the last question.
No, I don't have a question, just a comment or suggestion. What you're doing there is also highly interdisciplinary, right? So you're talking about the perception of speech, understanding of speech, and the lip sync and so on. And there is a lot of research on this in other fields. So I know a colleague of mine from UC Santa Cruz. His name is Dom Massaro. He's a professor now, retired. He has worked on this problem of lip sync and the connection between perceived speech and the visual perception of the lips for 40 years. So he has a book on this topic out there. So maybe it would be a good idea to also just check it out to see if there is something that could be applicable here in this research. Dom Massaro, and it's about talking heads, and the book is entitled what is it? Perceiving Talking Faces.
Thank you so much. Yeah, definitely.
Thanks, Dietmar. Okay, let's thank the speakers and move to the next presentation. Who is next? I know. Camille, I think you're next.
Yes. We can use the blue one and then, yeah, share. All plugins, maybe.
Sorry for that. Okay, so
I agree with all the problems that Yanis just listed before my presentation as in comment to previous one. And I hope to give you like a bit of fresh perspective with this presentation and give you also new angle to attack problems both in IMG and in Sogai. And what I will do is use simple psychological terms. So stay with me. I was using them to understand the scores that we have in the VQEG project, which was well, quite unexpected. And also this perspective that I will describe it today also give me quite good understanding of what might happen in the IMG project. So the main goal for today, okay, it's not changing right now, yeah. Okay. So the main goal for today is a summary of most important threats that I see from this perspective with the study both in SOC AI and with IMG project. And the discussion about the ideas how to deal with them. So I hope at the end you will stay with me and at least share some ideas how to deal with it. So as I promised, I will start from something simple. So I would like to take out your phones and answer one question, which is in this QR code. It will be simpler that way. Okay, I have 21 answers, so I think it won't be better. I would share the screen, but I don't know how it works, so you have to believe me what I will read. Like 72 of you, so 18 people answered that it's medium-sized dog. 3 people told me that this is small dog, and 4 people told that this is big. So is any one of you told that it is small or big and would like to share with me one thought? So who wrote that it is a small dog? Okay, Lucas, do you have a dog? Is it big or small? Yeah. Small one, okay. So you have some reference, yeah, in your mind when you are judging the dogs. But in general, did you find this task easy? No, why not? Okay, so you overthink it. So it's hard to stop being, I guess, quality expert. But yeah, it was reference to other dogs. But in general, it was quite doable, and we have quite consistent scores out of this small pretest. I was doing the pretest for people who are not working on the quality, so my friends, and they didn't have a problem to say, they all say 3, so it was a bit simpler. Yeah, but the idea is that you've seen in your life like lots of dogs. So then rating one dog in terms of the size is quite easy task. And with the video people that we are measuring right now who comes to our lab, well, they probably seen YouTube. Like 47% of population right now see YouTube once a month. In US, it's 77.7% of adults who seen YouTube. In Europe is depending on country 75 to 85. So it means that people who are coming to our lab probably seen this also. And there is good chance that they've seen screen like this before. So what it gives us when we score the quality of video, we have people who know that there are different video qualities. This is not obvious. They know that quality is somehow connected to internet, or they even might know that it's somehow related to compression. They have seen different qualities, and they can distinguish which one is good and which one is bad. and what it makes good quality and what makes it bad quality. It's not obvious either. Yeah, they might have some preferences, and they know that it can be rated, yeah, if they've seen this 5-point scale before. So they understand the task that we give them when we are asking to rate them the video. There's a small problem. Some of them might see better quality and they used to better quality, so they have bigger docs. Or some they might use to lower quality, they have lower docs. So like perfect participants would see lots of different qualities and have quite big reference in terms of quality. But it's not that bad because during the typical video experiment, we give people like 200 videos and they can learn, yeah, during the task. So yeah, all this information that you know how the quality is changing and you've seen lots of qualities, it could be described as schema in cognitive psychology. So schemas are description of patterns of thoughts or behavior that organize in categories of information and relationships among them. So it's basically what we ask people to do, yeah? They come to lab and they categorize the information and try to set relationship between the stimuli. So examples of schemas are mental models, social schemas, stereotypes, so on and so forth. They all have similar purpose. Thanks to schemas, we can survive like every day. So schemas give us fast answers. So you don't have to overthink every time. You can use schema and somehow simplify the word around. Yeah, so we might call people who are usually coming to our lab that they have really well-developed schemas, yeah? They know all those things and they see different qualities. So it's quite easy to measure them in terms of video quality. So what happens if someone has not like fully developed schema, yeah? So there are two mechanisms that they could use. It's either assimilation, so they can try to fit information into existing schema, or accommodation, so change the schema. So accommodation, it requires labor. In general, we try not to do it. So it is changing your mind, and it's usually something that you not do it easily. Yeah, so imagine what happened if you don't have like really developed schema, or your schema is biased in one place. So we've seen lots of dogs, we are adults, but you might see, for example, kids who only mostly seen their dog and it's small. So the schema of a dog is that dog is something that is small, is long, it has 4 legs, yeah? This is basically the schema of a dog. Yeah, so what's happened if this child seen a big dog? It can either change their schema or try to fit it to the schema that this child already have. In this particular situation, the kids could call this dog pony, yeah? Because it is like the closer schema that it has. Or accommodate, change the schema, and have the idea about the dogs that it can be either very small or very big, and they have 4 legs and so on and so forth. So yeah, when I was a child, I actually called this big dog pony. So this is like funny story from my life, but it's actually what, if you have kids, you might see similar mismatching of schemas. Yeah, so now please imagine that you never seen a dog. Is it easy? Yes? That's good. Okay, so let's imagine that you never seen a dog, and yeah, now I'm asking you, how big is this dog? It is not longer, if you thought that first task was hard, this is much harder, yeah? Because this is the first dog that you ever seen, and I'm asking you how big is this dog, so it's quite problematic. So in that situation, you start to have biases. You can use different biases to somehow deal with this task, yeah? Okay, I don't know. Yeah. There, okay. I see my presentation, so I don't know. I don't think so.
dial and redial the event.
Yeah, sure.
I needed the event information. Maybe you can make it.
Beautiful. Thank you very much. Yeah, so. Okay, so going back to the topic, yeah. So if we have a person who has not developed like really good schema of the quality, this person might be biased in a way. I call those effects like positive bias because it gives you like higher scores on ACR scale. Yeah. So there are just examples, but for example, the emotion O is something that it's not common in psychology. So it's the emotion that something is awesome, but it's also terrifying. And the study I'm citing here is actually using VR to bring this emotion because it's not obvious. And we have the wow effect. We have social desirability bias. So people will try answer something that they feel is desirable to answer. There is leniency error, and this is actually for scoring other people, but I think, and I feel it, and I've seen it, that some people coming to our lab seen us as authors of the system, and then they are feeling that they're editing us. There is accuracy bias where people are giving positive answers, and there is halo effect. So in general, something that might be awesome in your system will gives you answers on different scale higher. And this have consequences from academic perspective. With these biases, you will have null results. Yeah, so you might have some hypothesis. People are scoring only higher on the scale, and then you don't see the differences, for example, between different conditions, and that's problematic. The problem from the industry perspective is even worse, because you might actually put on the market product that is not ready to be there, or you overprice it. And I think the example of that is Apple Vision Pro, which might be that case. There is central bias. I think this is quite obvious. People are rating in the middle because that is the safe option. It's not that bad as the first part of the problems that you will have, because it's quite easy to find outlier or to remove that people. You can have negative bias, so-called. There is ambiguity effect. So in the experiment, if you are not sure that something that will be better for you, you are not sure of the outcome, you might actually choose something that is well known, but it's less benefiting for you. So for example, if you are comparing VRs to telephone, someone might choose the telephone because it's well known. And the last one, and from my perspective, the worst, I call it chaos bias. And there's like umbrella term construct irrelevant variance. It's when people are scoring totally different things on a scale. And this will give you p-values, this will give you publications, but not necessarily measure what you would like to measure, yeah? Because you have variance that it's not coming out from where it's supposed to. Going back to docs. So if I start asking more questions, it is even worse, yeah? So you never seen a dog, and I was asking about the size. Now I'm asking about the intelligence, about the temperament, about the gait, or about territorial aggression of this dog. And to some extent, situation when you put someone for the first time in VR and ask about social presence, it's like asking an alien to, you know, say something about spatial territorial aggression of a spaniel. Yeah, it might be problematic. And I would like to bring the discussion after this part, but first I would like to know if you have some questions for this part.
This is very clear, at least to me. Thank you for putting it together. Just have this blanket. I'm not saying it's the solution to all the problems you mentioned, but given that we do acknowledge without knowing the reason for it, and we have the ability to calibrate or correct scores for a general, because I only saw the term bias so far. Yeah. Minus, plus, right? Can we just capture that through the statistical analysis?
I think like central tendencies, or when you have just higher scores, it's something that you can call. That's why I told you that this last part, when people start to answer randomly, this is the absolutely critical failure of the, because you will have some effects. Yeah, you may publish it really well because you have positive values, and we are looking for positive values because we are also biased during review process. And this is critical failure for me.
All right. Anybody else questions?
Is any of these biases capturing the fact that you asked the question and that makes me think more hard about things that I would normally find easy? Because in the doc, I was looking at it, oh my God, maybe they made it with AI, maybe it's like small integrate. There's the perspective there, and suddenly you start overthinking, right?
Yes.
This could be also the case when somebody comes to a lab and it's like, oh, they're asking me about the quality of this video. Maybe I'm supposed to actually. So it would be probably like pleasing, but
yeah. So yeah, we'll try to do what is socially appropriate. So you try to figure out what is the goal, and then you start to behave weirdly. Yeah. And with video, it's quite easy, because people quite used to it, yeah. But with new technologies, it's even worse. So we probably have lots of these biases in video studies, but less than new technologies. And also at tomorrow's presentation from 5G KPI, I also will show some new results with ACR scales for two-dimensional video and cite like 5 papers from last year where influential factors are not really influential. So people are quite robust in terms of video, but it starts to be problematic even more with new technologies. Okay, so maybe I will start the discussion. I would like to list you like 3 ideas, and then we can discuss over them. So yeah, first thing that we could do with this problem is to train people. I know that it is controversial idea in this venue and has some problems, especially from Gen AI, like text to actually video or image. We will have the problem that we don't know how to operationalize the quality here. So it's easier to train in VRs when you can, for example, set different types of bitrate and start to train people. With Gen AI, it is much more harder. My favorite one, arbitrary sampling. So actually get the people who are using VRs or get the people who are using Gen AI on daily basis and use them as the testers. And this is not easy, but in my case, one of the best options. And like minimal solution from my perspective to the interviews and questionnaires after the test, but not about the experience, but how people use the scale, how they understand the task, what they actually were scoring. So about the process of scoring, about this cognitive process, about taking score to stimuli, not about the experience. Yeah.
Okay, I will start deviating for your questions for the beginning. Apologies for that. But something about the scores as well is that, so something that we know about measuring video or audio quality is that more or less people tend to know the task and behave in a way. This is this paper. I mean, well, there's lots of papers about that and your own work, but this I'm thinking about this SOS paper from Tobias. That he found that there's a statistical regularity on a lot of different use cases, right? Which does not hold when analyzing the data from rating movies, for instance, right? The statistical properties are different, right? So as a very beginning, if we are rating something different, we might be in the situation, in a rating movies situation, right? So we might be in a situation where everything that we know from the statistical analysis of subjective ratings doesn't hold because the underlying distribution is totally different, right? So it's not a bias, it's a totally different problem. And I don't know how, I mean, where we are when we are asking people to measure things, right? So do we know the properties of these scales that we are developing for other things different from perception?
Yeah, I mean, like the whole point of this presentation is like we put lots of focus on perception and we left the cognition like alone. So the rating process itself, I think it's something that we should put more like attention to it. Yeah. So how people are scoring. Yeah. It's supposed to be discussion, so.
So speaking of bias, you mentioned a lot of biases. With all three of them, or first two, are we introducing some bias into the testing methodology itself? Because if we train them, obviously we're going to get better, more aligned results, but are we really capturing the information from the people, right? Same arbitrary sampling. If we only use people that are using VRs, those are specific types of people, right? So again, it's a discussion. I have no answers to this, but there are more biases that you can also introduce as a tester, right?
Yeah.
Which we know as
Yeah,
well.
of course. I totally agree with that point. And that's why I didn't say that this is the solution. I would like to discuss this as the ideas. And for me, at least this bias supposed to be consistent, yeah? So you can have something first stable version, for example, of the metric, and then you can see how good it is in other situation, yeah? So maybe having this weird type of data with the bias would be first step into something better in future. But it is only my opinion. Like there's no good answer for that.
So I'd like to talk about the training topic. Having done a lot of video quality over the years, remember we used to have expert viewers, and what made them experts? It's always questionable, and then I used to joke, every consumer is an expert on video compression because they've watched a lot of television.
Yeah,
And
exactly.
they know
So
what's a
the
good
schema.
picture and what's a bad picture. So my view in the end, to get some of the variability out, I'm a fan of training. So depending on what you're training, show some examples, of the dogs, to use your example, to the folks, and then test them to make sure they really understood it, to try to get the biases out as much as you can.
Right.
And then, that will hopefully give you more reproducible results. The other thing is, we're doing all this objective testing to optimize certain technical parameters. For example, now I always joke, compression's never been shown to improve picture quality. It's all about bit rate reduction. And why do we want to reduce bit rate? Because it's cheaper, or we can put more programs in the same bandwidth. So the parameters that we're testing for also, I think to some degree, should go into that training aspect.
Yeah. Yeah, with the training, go maybe. Pablo first, okay.
Yeah, I mean, in that situation, especially if we don't know too much about the task or about the properties of what we are measuring, I mean, I think that training is a good thing. I mean, anything that narrows the task so that we are sure that we have measured what we want is probably better, because people will learn anyway. So people will build their own simplification anyway. So if we are sure that we are giving the simplification that we want, we will at least, control the manipulation. Otherwise, we are not doing better. Or I'm quite in favor of testing like small things rather than pretending that we are really mimicking the ecologically valid stuff and then, simply losing control of what we are testing without gaining too much. And kind of answers also your.
And I think it's also like, for us, it's our like new question, like how much training is enough training, how much training is too much training, and how much training is not enough training. So we have new questions here to answer.
you also can have different type of training, because
Yes.
for sure you can train people to, let's say, to familiarize with them with technology. Because, for example, I made when there was a hype for 3D, I made some tests, and people came to our lab, and the wow effect was really high. The same situation was with VR, and people were, let's say, they didn't have a reference. So maybe the training will not be focused on what you want to measure, but just please use for a while this technology, come again to the lab and play VR games, for example, not use it as technology to watch something. Yeah. So I think that all those proposals you present here can be, let's say, can be differently defined, and we can think about different definition of these ideas.
Yeah, just from my point of view, you touched upon a topic that I think is very critical. In traditional audio video, we had this knob called bitrate, right? To degrade, improve. How do you produce a bad looking flower? Today's LLMs, let's say your use case, quality of completely artificially generated images, right? And you ask 3, 4 models and they all look I mean, really good, right? How do you create the 1, 2, and 3 in your ACR?
In a way that is consistent, yeah.
The answer could be, well, maybe we do not need an ACR at that point, right? That could be an answer. But we do need to find a way to somehow degrade, right? If we stick with the classic ACR. That's, I think, one problem. Unless now LLM is so intelligent that you say, I want something not as beautiful, right? And then boom. But that's a successful output of a model. If the prompt is, I don't want something that's not beautiful, you should rate that a 5, because it delivered something that you asked for. So again, I would say that these are the problems that I'm thinking are amongst the most difficult, right? How do you create a stimuli that represent a gamut of qualities? Then what question you're asking, is it going to be the classic ACR? And then how do you now go into someone who has never seen generated content, right? Never, does not even know it exists. What question do you ask there? If there is no context, right? Okay, this was generated artificially. The prompt was, give me a beautiful flower. And this is all, like, as you say, completely unknown. So we do have to solve these barriers when it comes to evaluation of generative content. So we have multiple pieces of the puzzle missing here. These are my thoughts.
Yep.
So this next question, which I'm going to ask, is might open a can of worms. So in the subjective studies that we did, one thing I noticed was the user fatigue with the study. Like, if some people are reluctant to vote on more than 50 samples, and it starts to show in their in how they are choosing which samples are better. Have you, like, do you have any studies on that, or is there any biases or any papers on that which can help us determine that for this kind of a study it might be useful to have these many participants doing this, looking at these many samples? And
I think you cannot omit fatigue. Yeah, like, this is yet another problem that with two-dimensional video, you can put like 5-second samples and put a lot of them and have lots of data points. And with VR, you have less of them. And so in general, by default, you have less samples, and then I'm told you to apply training. So this data become more and more, with this approach, the data will be more and more demanding in terms of gathering them. Yeah, so longer tests, maybe gathering participants a few times to the lab, paying them more, things like that. it is the price.
And I think maybe in a few minutes. we need to
Yeah.
Well, I want to pick up what you were talking about, Yanni. I remember someone once quipped to me, when you don't know where you're going, any road will get you there. So I go back to my point that to answer your question, if you ask me, well, what would I want to see? I want to see the most beautiful flower possible. But we're doing this in the context of trying to address some technical issue. And in VR, things that bug me, not necessarily the bit rate, but the early goggles had very poor pixel arrangement. So I don't like looking through a screen door. It doesn't look real. So if that's something you want to measure, well, then the test content you would provide would be, again, to solve that problem. So to me, the training goes back to an understanding of what problem we're trying to solve, and then do the appropriate content creation and training of the users to give us results that go back to address that technical consideration. Yeah.
Yeah, so I think we just heard the two concrete examples, right? We are trying to help people make better auto dubbing, for example, right? That's one use case, right? How can we help that community? Ideally by providing the metrics that they can run after the, let's say, automatic translation that says, okay, that's very good. How do you obtain that metric? By asking people first, getting the baseline and fitting a model. That's like the playbook we've been following, right? So now the next use case, in my opinion, the most difficult one is multimodal LLMs, right? Multimodal LLMs. How do you evaluate whether this is better than that model? This produced a flower, this also produced a flower. What metrics are you running there? And again, it's not just the flower, but the prompt that generated the flower, right? Because again, if the prompt goes, I want an ugly flower, you must take both the prompt and the output of the LLM and evaluate and say, this model achieved a score of X versus that. So it's not just the visual part, it's not just the audio part, it's the prompt, the text, perhaps the image that was modified. So the problem we need to solve is to take whatever was used as an input, whatever was the output, and holistically assign a score to that. That's what the community and the people who deploy products need today. Yeah. And in the absence of that, they're using proxies that end up being usually pretty bad. So the alternative is, I would say, not as attractive. But again, we're almost at time. Let's thank Camille. And let's wrap up today with Patrick. Plus a few slides, concluding slides from Abhijay. So let's a few minutes to wrap up this session.
Allez, this is not exactly what I wanted to present, but it's to make a transition from what we just discussed and what I'm gonna present later on. So This is some thoughts from a good friend of mine, actually one collaborator, Wang Taozai in Jiaotong, Shanghai. And this is his vision of a future of visual quality assessment. Exactly jumping on what you were saying, Yanni, with LMM, large multimodal model, not a large language model, but LMM. And maybe we are shifting from media assessment towards model assessment. And in VQEG, we are used to do media assessment. But these days, maybe it's towards that direction we need to go, because of course there is human, you have AI generated content, whatever, and in between you have the LMM in the middle. So, and I like this, the fact that basically to maybe evaluate model, we need to, we can borrow the psychophysics approach. So the things that we are doing here when we do tests for media assessment, and how we can transfer this psychophysics approach to a test LMM. Maybe it's more than test of knowledge, it's also test of intelligence, all these type of things, and maybe that's something we can discuss a little bit more, just to give you also a glimpse of such things that they are doing for benchmarking LMM. This is a very nice paper. I can give more details on that, but you see they try to have this taxonomy where you have on one side the quality perception, technical quality perception, as we are used to do here in VQEG, aesthetic quality, generative distortion assessment, so things which are maybe, let's say, not fulfilling physics or whatever. So, by the way, this is also a big movement these days, where people working in robotics are joining people working in computer vision and try to have a more physics-driven approach. And then there is on top here the semantic understanding. And there are a lot of things which are very interesting: basic recognition, bag of word, pitfall discrimination, outside knowledge realization. So I like particularly this one. Maybe I can zoom a little bit. So contradiction overcome. So if you can test an LMM with this, is the moon larger than the sun in the image? Of course, if we know that the moon is supposed to be smaller than the sun. It's not the size of the dog here, it's the size of the planet. And of course, if you based on some knowledge, you may LMM say yes, but why if you don't interpret the things correctly in the image, actually the moon is larger than the sun, it's bigger. Anyway, so that was just to extend a bit the discussion. So let's try now to go from the presentation that I have for you. No, okay. So one thing we did together with Guangtao quite recently, and I want to provide that. It's a proof of concept how we can do quality assessment of AI-generated omnidirectional images. So I don't know where to put that, in SOGAI or IMG, but it's basically a bit of both. Okay. And if you are wondering what is on the bottom left, Jesus, what is this? What is this? It's a video inspected. So it's quality of a video in an egg. So it's probably VQEG. Voilà, the Video Quality Expert Group as a logo. So AI-generated omnidirectional image. So of course, it could be, it has huge potential, especially for VR or AR, because when you want to develop ER or VR environment, it takes a lot of time. So having a possibility to generate omnidirectional image is kind of appealing. But so far, let's say, we don't have much control on this, not much control on quality. So it's a bit of interesting to start to study these things. So this is what we did, and we provided a first data set so-called AI GCOIQA 2024, which is composed of 300 images generated by 25 scene prompts, 12 indoor scene, 13 outdoor, and using 5 omnidirectional generation model. The prompt is interesting also because you can play with LLM and LMM. So we started from some sources, natural content, 25 omnidirectional image of natural content. Some were coming from a data set that was provided in MVD diffusion. Some were coming from the data set Sun 360. And from that, what we did is we tried to generate some prompt. So we take the source content and we use LMM to describe what is in the image. Okay, so it's a image to text. So for this, we use the blip2 to annotate the image that generate a preliminary prompt, and then you refine again this prompt using ChatGPT-4 to add details and polish a bit this prompt. But you know we are using here so LMM plus LLM. Then, once we have this prompt, we can generate new content using a generation model. So in that context, we use a 5 model, MVD diffusion, text to light, DALI, Omni in painting, and a retrained version of stable diffusion to generate omnidirectional images. So this was done using some image coming from a blip2 dataset, label indoor, outdoor, and so we could retrain stable diffusion to generate ERP image for omnidirectional diffusion. So one thing we can look at once we have all these PVS is a statistical analysis of what we have generated. So there are more statistical analysis in the details that give you some of the, just one analysis which is provided here. You can look at the distribution of the features, sharpness, contrast, colorfulness, brightness. And you see for these 4 features, red curve and yellow curve corresponds to natural content, okay, things that you can capture, and you can look at the distribution of what is generated by this, the 5 models that we have done, and this is a blue curve, and you see, depending if you are dealing with contrast, sharpness, or whatever, generally, the distribution match more or less what you get in natural content, which is okay, a good sign. But more importantly, I think it's a good tool also to measure, and we have a lot of metrics on our side that measure sharpness, colorfulness, and so on. This is really the technical description of quality. So from if you want to assess this part of AI-generated content, maybe you can already use this. And it seems that so far the algorithm on that this particular feature are working pretty nicely. So now subjective scores, that was the discussion. What should we rate? What should we ask to the observers? So that was the first attempt here. And basically 3 dimensions have been considered. And it's probably much less compared to what I was showing at the beginning of the talk. But there is the quality, okay? So we know what is quality. And because we are dealing with VR, we can say, okay, let's look at if this image generated by generative Gen AI, are they comfortable or not? And because we are going from text to image, we can also check the correspondence. So it's mostly prompt related items. So can you rate the correspondence between the text and the generated content? So this is the 3 dimensions that were asked to be rated to the observers. So you have a different image, and each time the people they have access to the prompt, and they have to rate on a scale from 0 to 100 the different dimensions. Of course, this triggers all the problems that we have already faced for 3D TV, IMG, when you have to measure several dimensions at the same time. How people read this? Do how do they understand the different dimension, how they manipulate the scale and everything. Well, anyway, in the paper, we report also the most distribution on each dimension, which is kind of interesting also because you can see that, okay, from the quality viewpoint, distribution is kind of interesting. This is usually something, this type of distribution for mean opinion scores is something that we like when we run a subjective test. Comfortability and correspondence. So you see that it's kind of biased, but in a it's a tail distribution and towards higher qualities. That means that the correspondence text to image seems not that bad for this particular content. The last thing that we have in this paper is can we measure the objective assessment, especially using non-reference metric. So we have first one, because we have the quality score, the first dimension. You can use on-craft-based model, mostly the ones that are designed as non-reference metrics to measure image quality. Another type of metrics is CLIP. So you know that CLIP is a visual language model. So how you align text to image. And in that case, we took as a score the cosine similarity between the text and the image embedding. I don't know if you are familiar with CLIP, but basically you have an embedding for the text, an embedding for the image, and you have a similarity between the two. And this is what was used here as a benchmark. And finally, there was some deep learning-based approach where here we retrain the stuff. So with a ratio, because we have a data set, 300 image, you can retrain these metrics. So in terms of quality, you have some kind of performance. You can see that the metric are more or less performing well, but not. Keep in mind there are non-reference metrics. In CLIP is not working that well for the quality dimension, and here we got some kind of decent result with when you retrain stuff. For comfortability, so excluding the image quality metrics for that, because you cannot retrain that and them, and so it's pretty unfair to benchmark that because they are not tailored to measure comfortability. And you can see when you retrain stuff, you can get some kind of a result. And finally, for the correspondence, I was a bit, let's say, puzzled by the fact that the CLIP score is not that good, but retraining metric is possible. So it was just a proof of concept, things that can show you how we can also run some kind of experiment to generate PVS, measuring where we are, even the generation itself. If you do the analysis from a technical quality viewpoint, you can measure distribution and stuff like that. And that's something where I think VQEG community is kind of comfortable. The question of what we rate then with subjective score is one thing. And then, yes, we still have some possibility to retrain stuff. And with that said, I want to finish this talk with, yes, the former VQEG logo from Caroline and TIA.
Thanks, Patrick. Okay, questions for Patrick?
Just curious, why only omnidirectional? Why can't it be just anything? Because the way the data set was constructed is pretty generic, right? So it can be extended to any other.
Actually, this is already an extension of a data set where it has been done for image and video previously. So today I wanted to show the latest data set we did, which is omnidirectional. But of course, we started with image and video. So
Thank you.
Any other questions? So for the setup, the questionnaire had these three questions, right?
Yeah. So it's in a HMD. So I did not.
Overlay.
And then you have to
What
write.
one, was it ACR 1 through 5?
No, it was I think kind of a SSCQS single stimulus.
So that's where the score is. 100, right?
Yeah.
Okay. I see Milena, but Abhijay, you're first.
Thank you so much for your presentation. It's really good. So my question is that when you were choosing the metrics, I think CLIP score for quality would might not be a good one because it focuses more on the aesthetics in the image. I think there's a paper where they did some experiment and they put the quality on the x-axis and aesthetics on the y-axis. They put a bunch of pictures and then saw where the clip score is, like what clip score predicts for those images, and it kind of was more biased towards the aesthetic quality.
Yeah. Was it also was they using in that paper also the score was this also the cosine similarity between text and image embedding? Yeah, similar. So it was the same.
I think that paper is called Human Preference Score or something. HPS.
Okay. Okay.
Maybe trying that metric on over here for quality may give good results as well. I'm not sure, but there are also other metrics like Q-align, and there are a few others. Like NIQE is also a good one, and seems like it has a good high score over there, even without having been fine-tuned on the data set. Yeah.
Please use the database and use this visual language model on this because everything is available. And but thank you for your feedback because it explains also why a clip, at least it's another evidence why clip is not that performant for this type of things because it's a bit biased towards aesthetics. I take this one. Yeah. Okay.
Yeah. There's actually a specific clip IQA method for quality. I think.
Yeah.
Yeah. That might also give good results. Yeah. Thank you.
Yeah, but it was not developed for the, I think, omnidirectional, this one, clip IQA. So you need to do a bit of a trick to make it work for this case. Yeah.
Patrick, I was just curious. So how do the bad qualities look like the videos with bad, the omnidirectional images with bad qualities look like, and the good qualities? Because we were just discussing about this, about what would be good and quality, about everything. Some, yeah, because yeah, but I mean visually, how do they look?
Yeah, because you are not generating, let's say, compression artifact. It has nothing to deal with that.
Exactly.
So it's it can be. So you don't know if it's about sharpness, blurriness, colorfulness. All this.
So I'm just wondering.
Yeah.
If how do they look? Is
consistency across the image or these type of things. Frankly speaking, this is very preliminary. When we used 3 dimensions here, and we don't know exact, and this is something that is missing, I think, in the paper, is to see if this dimension correlates somehow a bit, and it might happen because when you test all these dimensions in the same test, so you have an image and you have to rate 3 different dimensions, we know that there is a risk that some observers will start to correlate things, misunderstand what you want to rate through quality, comfortability, and text-image correspondence.
Because I'm just curious because, for example, like one of the talkers presented, sometimes there are errors, there are faces which are not faces, fingers. I don't know. I remember watching a video.
Yeah, this is
I don't know. There were weird things going out. So would they catch it in this case or no? Would it be perfect? And then if they don't, would the semantic ones be better? Because I keep thinking the semantic might not be so bad.
So this dimension you are mentioning are supposed to be in comfortability, which is not only about the comfort level in VR. You see, there was also the authenticity level and the structure deformation. So it's 3 concepts in one dimension, comfortability. So this is kind of questionable, this. But the things that you are referring to, things which are not natural or stuff like that, are not supposed to be taken into account in quality. Nevertheless, when you look at the distribution of the mouse, look, the distribution of quality and the distribution of comfortability looks a bit similar. So it will be more interesting to have the 2D plot and see if we have a specific case here.
Relation.
Yeah.
Okay. I see Balu, I see Lucas. Do you wanna? Okay. Because I was about to give the microphone.
Socrates, Lucas, you are allowed to do the question and the answer.
Thank you. I'm paid by the question, so I can't miss the opportunity. Can you please show us the examples of there? Because I really have a question about the dimension of quality here. Because if you look at the images that have high quality here, and you are talking about the low level quality like sharpness, colorfulness, naturalness potentially, I'm just wondering that, you know, the ones that seem to be having like 70, 67, it really depends on what the person looking at the images is looking for. Like, yeah, they are poppy, they are really contrastful, right? But for example, if I was somebody who generates it to use it in my presentation, I'm not sure if this is really something that I can work with. So this is mostly just tying it back to Camille's point, this like, since there was no training or no extra explanation what the quality actually means, you know, I'm just wondering how well we are actually capturing this low-level visual qualities, because even though we may have described it to the users, how they interpret it doesn't seem exactly, for example, how I would do that. Or and then maybe be coming back to your point, Yanis, before is, you know, what are we actually measuring here? What can we even you know, some narrow it down, or is there a way, or did you do some sort of analysis on how do people understand it, or maybe then the questionnaire would be good, or anything like that? So did I do also the answer to it?
Partially, yeah, I think so. Yeah, 90%. So thank you, Socrates. Yes, no, the air quality, you see, it was low-level visual quality, so it was color, lighting, and clarity. Let's not forget also that there is another dimension, which is how you interact with the media and what you explore exactly. And so it's another, let's say, cause of uncertainty. And knowing that we had 20 observers, no, which might be enough when you control everything on 2D, but in a 360 immersive environment, I'm not sure. I'm waiting for the recommendation of IMG on this.
More work for everyone. Okay, I think Balu will ask over dinner his question, and I leave it up to Abhijay to wrap up and maybe share a few slides. Thank you, Patrick.
So I don't have. Oh, sorry. Oh yeah, just wanted to share that we just wanted to advertise our Discord server that we created, and just reiterating Yanis's point that we are currently things are moving really fast in this field, and we would like more discussions, more people talking about papers and ideas, and hopefully and more collaborations across institutional boundaries. So we'll send out invites on the email reflectors, and I also just wanted to touch upon like this image that I showed last time. I was just trying out the Gemini 2.5 Pro model, which is the latest, the best, and it also fails to accurately say that that the dog's hands are incorrect, or the anime over the person standing here in the anime is it like is this true or natural in some sense? It does not predict any anomaly over here. So these are the kind of things that we might look into in Sogai, and also just wanted to showcase this one example that I tried more than a year ago with GPT-4V, and it's giving such accurate description for this particular sample. I tried a bunch of samples for video frame interpolation quality assessment, and I realized that I was getting like 100% accuracy, close to like really good accuracy. for this task. And so these are very powerful models. Also reiterating Patrick's point that LLMs for LLMs can really work. So we're going to look into some of those latest things, discuss those, and probably come up with collaborative efforts. Thank you so much. Thank you all the presenters. It was a really enjoyable and knowledgeable session for everyone. Thank you.
And again, thanks Abhijay. As a personal request, Soga is a new group, and I really applaud the younger and fresher members of the team who stepped up, like Abhijay, Lucas as well. They took the challenge, but I would like also to see the wisdom from the people who have done this longer time to maybe convert. So please, if you have the cycles, join the group, offer your insights, and let's see if we can make something work. I can say that industry can use quickly. Okay, before we go away, does everybody know where is the restaurant by now? No, that means you were not here in the morning. Let me repeat. The name of the restaurant is Trellis, like the famous algorithm to decode the channels, Trellis. It's in here nearby. Let me share my laptop here. Yeah, so first of all, it's already on the Google Doc, the one that has all the instructions, how to come to the campus, etc. I added it there. So yeah, please stop the recording. Yeah, remote participants will only be jealous now.